Ah, you're more of a Morty than a Pickle Rick.
No, I'm too sorry.
Or maybe you're more of a Jerry.
No, that's the worst. What? Not this Jerry.
No, different Jerry.
Yeah, different Jerry.
Pickle Rick Jerry.
I rather Morty than Jerry.
Okay, what shall we do first? What question? Tutorial. No, it's good. It's good, it's nice. It's nice. Monica, no, leave it. Monica, leave it.
No, please.
No, Jerry, no.
I don't stop it.
What questions do you want me to do? It's tutorial time.
The standard deviation is the sigma.
Yeah. Or S. I can wait here all morning. What do you want me to do? Tutorials. You remember how tutorials work. The questions you're supposed to be doing at home. You ask me for help when you get stuck.
But it starts with statistics.
You've had no problems.
I solve all questions.
Really?
Yeah.
Really?
Where's that, teacher?
That's today's question.
Which lesson? Normal distribution, okay. So what page is this? Question. Okay. Go for it, read it to me.
The mass of a fish
Mm.
in a pond. The mass of a fish in a pond. Is the mass of fish is normally distributed with the mean to 50 grams
Okay.
and standard deviation 4 grams. A fisherman catches 9 fishes. Estimate what is the largest fish he caught.
That's a tricky one. So you have a fish and they're 250 grams on average. And standard deviation is 4 grams. And he catches 9 fish. And you want to know what do you think the biggest fish, its mass will be. Yeah? Okay, so what's the best way to explain this?
So maybe a normal distributor.
Huh?
And then find the largest.
Yeah, well, hang on. Oh, that toffee sweet stuck to me. It was good though. Okay, so let's imagine we had 3 fish. To make it a little bit easier. Let's say you caught 3 fish. What do you think would be the best, or rather, what do you think would be the most likely situation if you caught 3 fish? Well, let's start off with 1 fish actually. That would be even easier. So if he caught 1 fish, what would be the most likely mass that fish should be? Roughly. 250.
Yeah.
If he caught 1 fish. Now, gets a little bit harder. If he catches 2 fish, what would be the most likely outcome? Not that they're both 250, because if they're all going to be 250, what's the point in having a normal distribution? So what do you think is the most likely if we caught 2 fish? We kind of feel like one should be below the average and one should be above the average, so something like this. If he caught 3 fish, what would we expect their masses to be? We think one should be about average, one should be less than average, and one should be more than average. Now this is where we start to get the idea. When we have 3 fish, we can split this up into 4 pieces. And what do you think would be most likely? that these pieces are the same, or that they're different, or one is bigger than the other?
Different.
Most likely that they're the same. Now the idea is this: we can't predict the future yet. We can't know what fish he will catch. But if I tell you he will catch 3 fish, then the best guess we could make is that one will be average, one will be less than average, one will be more than average. Why am I saying this? Well, if one is average, one is less than, and one is more than, if you calculate the average of these 3, you'll still get this is the average. But why am I saying that they should be the same distance apart? Well, it's for a similar reason for the standard deviation. If you say most of them will be at the average, then you've made the standard deviation a lot smaller. So the best we can do is say that each of these areas will be 25, 25, 25 and 25%. Okay, so now let's jump to what we have. We have 9 fish. So how many pieces is that on our curve? We'll have 10. And each piece will be how big? 10%. Which means the one up here will have an area of what? Yeah. Will be 90%. Okay? So we need to look up the formula book. What value gives us at 0.9? If you have it on your phone, please, what Z, or the table of what Z will give me 0.9. Where's my fish gone? Yeah, here we go. Yeah. 1.28. So that means Z equals 1.28, which means X minus 250 over 4 equals 1.28, using the Z transform. But this time we want to find the X, because we know the Z. So that means X will be 250 plus 5.08. Is it 255? What is it? 5.12. So 255.12 grams. So we think if he catches 9 fish, then the biggest fish we think should be about 255.12 grams. This is a very hard question. In fact, I don't think it would be this hard in the exam. This is maximum difficulty +1. Is that even more difficult?
It's the same idea.
Is it? Well, let's see then. Question 24, you say. Okay, read it please. Hang on, 22? What's wrong with 22?
I mean, you said 21 to 24 all for passion for the
Others.
Artists, yeah.
You do all for
Did you try them?
no.
I feel like Monica has at least tried the one she's asking me to do, right? Or at least have thought about it. Right, 24.
A computer generates 10 random numbers which are normally distributed. The biggest number in the set of 10 is 7.6704.
7.6.
704. And the smallest number in the set of 10 is 2.3296.
2.3296. And this is in a set of 10. And I'm guessing they want to know the mean and the standard deviation. So by using the exact same logic of the fish, we can say that if I have 10 I'm looking here and here, which is at the 10% and the 10%. You actually know the Z here. It's 1.28. We had it here. This one here is going to be minus 1.28 because these things are symmetric. So it actually means you have this to solve. You have 7.6704 minus mu over the standard deviation equals 1.28, and 2.3296 minus mu over sigma equals minus 1.28. Yes.
Teacher,
Yes.
I have a question. I mean, how can it be 10%? Because
Oh, sorry, there's 10 of them, so it should have been 11. Yes, you're right, thank you. So it's not 1.28. We need to look up a different value. It's not 10%, thank you.
that is actually not my question.
Oh, well, if that's not your question, you still accidentally asked a good question. Just one moment, Lee. What's 1 over 11 as a percent? It's 9.09%. That's what we need here and here instead. And what value of Z will give me 90.8, 90.9, 9.09, 90.91. Isn't that right? 9, yeah.
1.33.
1.33, you think?
I mean, it's not. Wait.
Should be less than 1.28. Should be like 1.25 or something. How could it be? Oh yeah, sorry. Should be more than 1.28. Yeah, maybe 1.35. Or what was it, Christy?
No, I mean like it has.
I know, you just need to be close. If you can match as close you can.
I mean, it has the last
Yeah,
one.
there's 9082, there's 9099.
I mean, it has the last.
9099 and
82.
9099 is closer, so.
And 1.34.
Right, so you want to solve 1.34 and minus 1.34. That will give us the mu and the standard deviation. Although, before I calculate it, I have a very, very, very quick way to guess the answer. If I know the smallest value and I know the biggest value, then I feel like the average is probably right in the middle. Yeah? So what I could have done is I could have just done this. I could have said, I think the mu is roughly the smallest plus the biggest divided by 2. Yeah? And also, if I was to estimate the standard deviation, do you remember we said the standard deviation? Yeah, no, an estimate, or maybe we didn't say this. It's roughly how far away from the center our data is on average. So, if I know the distance between the biggest value and the smallest value, and divide that by 2, then I know the distance from the center to the smallest and to the biggest. But the standard deviation should be about here. So if I divide this by 2 again, I have a very, very rough estimate for what I think it could be. This would be better. This would give me like the exact answer. Although, in fact, I think it would be very, very close to these two. Yeah. Oh wait, hang on. Lee still has this question I stopped him from asking. Resume.
How can we assume that like beyond the max is 9.09? Because it is different with the fish example. I mean, in this case, the computer generates the number, and it has been given like the biggest number is 7.67. So it has zero chance that the number is bigger than that number. How can we assume that there's 9?
No. There's a 0% chance that one of your numbers in your data set is bigger than the biggest number, obviously.
Yeah.
That's what you're saying. But it's wrong to say there's a 0% chance that you could get a bigger number if you were to continue generating random numbers. You understand, of course, that if you took, Lee, if you took 10 people and looked at who's the tallest, you would understand then, of course, that in that group of 10, there's a 0% chance anyone would be taller. But it would be wrong to say that anybody ever would be taller than the tallest person in your group of 10. So there's still a less than 10% chance, a 9% chance that the computer could make a random number bigger than the biggest one it made in the previous 10. Make sense?
Yeah.
Are you sure, Pickle Rick? Pickle Rick will understand this. And he's a pickle. Okay. Now back to you. Your question was? It was back to my diagrams I had on the left here. If I had only one data point, then it's most likely to be in the center and splits it into two pieces. If I have two data points, it splits it into three. If I have three data points, it splits it into four. So it splits it into one more than what you have. So if I have 10 random numbers, I imagine the bell curve is broken into 11 equal pieces. It's okay? Yeah? Monica, this is okay? Although weird, it's okay or not? Yeah. Are all these last four questions similar to this kind of weirdness?
Number 22 and 23.
Yeah, 22 and 23, okay. What's so weird about 22? 22, go for it.
Consider F that will
Behaves like a normal mu. Standard deviation. Yeah.
Where mu is more than 0.
Okay.
Is more than 0.
Alright.
P into bracket 0 less 0.
0?
Then
Less than?
F
Less than.
not less than or equal to less than.
Okay.
Even the first one.
Okay. It doesn't actually matter too much. Go on.
Equals 0.01.
Wait, less than what?
1.
Yeah.
Equals to 0.0165 and P1 less than F less than 2 equals 0.0441.
Find mu and sigma. Right, so let me draw what we have here. We have a normal distribution with some unknown mean and some unknown standard deviation. What we do know x between 0 and 1. Now I don't know where to draw this, so I'll just put like 0 here and 1 here. I know this area is 0.01655. Okay, and if I look for x between 0 and 2, that area will be 0.0441. Okay, what I'm going to do now is Z transform. So if I Z transform this, here, this 1 would become 1 minus mu over standard deviation. Yeah? Now, I think in my question when I said mu is greater than 0, I think perhaps I should have said mu is greater than 1. It would have made it a little bit easier. But I don't know if that's what I meant. And the only way I would know is if you check the answer. What is the answer, by the way? Yeah, okay, so I meant to say mu is greater than 1 in the question. It doesn't really matter. What I wanted you to do was to draw this over here. Oh wait, did I mean this? No, I didn't mean this. No, disregard what I just said. 1 minus mu over sigma, will that be on the left or the right? Yeah, well, the probability of being between 0 and 1, oh, I still have to work out 0. 0 minus mu over sigma, and then 2 minus mu over sigma. Okay. Yeah, I'll just draw them on the right, actually. I will do what I said I wouldn't do. Okay, so there's the first one here, second one here, and third one here. And I have 3 areas. And the first area is 0.01655, and the second area is 0.0441. Whew, right. How do I get this area? I have to do this value minus this value. So, table of 1 minus mu over sigma minus table 0 minus mu over sigma, that should equal 0.01655. And how do I get this area? Again, it's table 2 minus mu over sigma minus table 1 minus mu over sigma equals 0.0441. Hoo-hoo! This is getting hard, because now I have to find these mu's and sigmas. But I've got a sneaky trick, I think. If I add these two together, yeah, if I add them, these two cancel. No. Minus them would be better, wouldn't it? No. Add them. Because basically what I have is something that looks like this. A minus B equals a number. And then C minus B, minus A. Yeah, they're the same as that, isn't it? Ah, but I have 3 unknowns for 2 equations. That's not cool. Although, but I could make another equation, because I could look at the total area here. Should be those two added together. So I could also say area 2 minus mu over sigma minus area 0 minus mu over sigma equals 2 of them added together. But I think that's the same as if I just add them, yeah. Is this even solvable? We have is this even solvable? Oh wait, I'm sorry, I thought this was 1 to 2. It's 0 to 2. So that changes this one to 0. Oh, I just wrote it down wrong here, was it? Okay, that's alright. You think to add them, Jerry? Add them. That will cancel these. Oh, pass, Stephen. Why did you make this question so hard? Sorry. What was I thinking when I made this? I have 2 equations with 3 unknowns. You see, if I could find A, B, or C.
What is 3, 4,
Hmm?
what is 3,
I need three equations. I have three unknowns, A, B, C.
What is
Oh, it's just A, B, C, A. I just gave them letters so I don't have to write them up. Yeah, if you add them, you still have C minus B. Goodness.
Or you make the wrong question.
Would it change anything from 0 to 3?
Huh?
What would change it from 0 to
No, so just that this last one here would be 0. But it still means three equations, three unknowns. Did I give you anything else in the question I didn't use yet?
No.
I made this way too hard. Just so you know, it is possible to solve this technically, because if you go back to this one here, how many equations do I have here? 2. And how many unknowns? Well, technically at this line, 2. What are they? Mu and sigma. This is quite hard. I don't think it's solvable. I made it so hard.
Funny enough, the answer for this is the same as 24.
That just means I reused my data to make the question. No, it's solvable technically and theoretically, but to solve it would require the use of a computer program. It can't be solved using algebra. And the reason for that is because there's no way for me to simply drop this function because I need the table book. It's not like this function just means to square. If it meant just to like square something, then we could just expand it, make 2 equations and solve. But there's no way to drop this without making some kind of error. I can only estimate the answer using algebra. I can't solve it unless I have a computer. So I've made this question so hard it can't be solved. So you probably won't get that in the exam. This question, unsolvable. That's what I get for trying to make hard questions.
If this is unsolvable, then number 22 also.
Is it something similar?
Yeah. Kinda.
Correctly, an expression that estimates what is likely to maximum value of x value.
No, that's not actually. This one is though. I mean, the only way you could solve this is you would have to look up your table book and try to find numbers that would go here, 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 and here. So you would want to find something like table book a number, I'll call it number 1, minus table book another number, so that the difference between these two answers is 0.01655. Then you would want to find table book a different number, minus table book the first number, and you want to find 2 numbers so that when you minus the answer you get 0.0441. If you can find these 3 numbers, then you can say that this equals the first number, and this equals this number, and then you can solve. But that's my point. That's why I said we need a computer program, because we need to check every combination. So it's not solvable for us, I'm afraid. Okay. Right, what's next then? Something solvable perhaps.
23.
23? Okay.
Solvable.
You say this.
I said it. Okay, read it, Monica.
S
Behaves like a normal with mean and sigma.
a computer generates n values for f, find an expression that estimates
The maximum.
the
Yeah. Okay, so look, if you have n values, then the maximum would be up here, and what would be the area? Here. Up the top here. If you had n. Well, remember, if we had 9, what is this area?
N plus 1.
No, okay, yeah. Well, if we had 9, what's this area?
10.
10%.
Yeah.
And when we had 10, it was, what was it, 9%. In other words, this one here would be 1 over n plus 1. So what would be this area to the left? It'd be
1 minus.
1 minus 1 over n plus 1. Yeah? So what's this value? Oops. What's this value of z? Well, that would be the value so that its area would be 1 minus 1 over n plus 1. Now you use this table but backwards. So for example, you look for area of 90% and then you read what the z is. You're going backwards. Remember, like earlier, when you said, let's find a number that makes the area 0.9091 or whatever it was. You have to find this number here. So the way we write that is, we write it like this. We look backwards in the table so that the answer is this. We do the inverse. So rather than checking the area for z, we check what z makes this area. That's how we can get the z here. But we know what the z is. That's x minus mu over sigma. So therefore our answer is x max equals mu plus sigma table inverse 1 minus 1 over n plus 1. That is the answer.
Is it 3 or 9?
Yeah, but the question was find an expression.
Oh, I thought expression can only have 1 unknown.
No, any number. Correct.
16 1
Disgraceful. I never wrote in n plus 1. Absolutely disgraceful. It should be n plus 1, as discussed earlier. What an outrage. Anything else? How are we doing for time? Oh yeah, we can do something else if you want.
Class dismissed.
Sorry, who died and made you leader?
Huh?
What?
What did you say?
Nothing.
I heard that shit.
Anything else then? No? No? Next time we will start doing exam questions.
Yeah.
But later today after lunch I will go to the physics workbook and we will start with
Excellent.
atoms in the workbook, which is on Moodle before you ask me. Again.
Are you willing to pay for it?
Am I willing? Yes. I'll print them for you. I'll try to remember.
Okay, but it's not because it's kind of wasting space of printing the PDF on like 1 page.
What?
Like how can you print the PDF of 2 pages in one?
Oh, I haven't a clue.
Like every time I print just one.
Because it's our computer lab.
Yeah, I think
Yeah.
you might not be able to print double-sided in your computer lab.
I mean,
You
you
can
can use
do
a
it.
copy.
You can.
do.
I don't know. I don't know much about computers.
Whoa.
I will print it double-sided for you later today.
Are you gonna give us math dividend practice?
I have to think deeply about this because I don't have as many past exam questions for maths as I do for physics. So I don't know if there's much point in grouping the questions together because there's so few of them. I might just do the whole paper one by one. Do you? For maths?
Yeah.
Yeah, okay, then we'll just do that for maths then. But first I have to download the papers again, fix that too. Anyways, that's for the next maths class. We'll do physics later today, starting with atoms.
Okay.